Hi everyone, and welcome to another episode of Mr. Carlson's Lab. The refrigerator at our house ended up quitting, I imagine sometime the evening before I ended up discovering it. Everything in the fridge was warm, everything in the freezer was thawed. A couple $100 in groceries had to be thrown out at this point, which is extremely unfortunate. But this gives us something now to troubleshoot. Now here's the thing, when I discovered that the fridge wasn't working, I didn't have a camera on me at the time. But here's the key thing, I immediately started troubleshooting the refrigerator and the freezer without disturbing it at all. And there's a few key things that I look for. So I didn't want to unplug the fridge, you don't want to touch any temperature controls or anything like that, you do not want to disturb it. These are the things you want to look for. Number one, is the compressor running on the fridge when the fridge is warm? Number two, when you open up the refrigerator, do the lights come on? When you open up the freezer, do the lights come on? Number three, do you hear any crackling in the freezer or the refrigerator? So if you listen closely, do you hear any like sizzling noise or crackling noise? These are the three key things that you want to be listening for before you do anything. If you unplug the fridge and plug it back in, many times it will reset. Now, most modern refrigerators are controlled by an IC. So by unplugging it and plugging it back in, if there's any relays in there, it lets the tension off and then some of the relays will come back on. Sometimes it will reset the IC so that it'll run through a process again. And this can really skew any troubleshooting for a few days. So these are key things. Do not touch anything and do those things first. Compressor, lights, crackling. Remember those things. We're going to go take a look at that refrigerator now, and we'll see if we can get this thing operating again. Here I am behind my fridge, and the controller board for this fridge is underneath this cap right here. So in order to get to this board, I need to remove these three screws right here. Now, the fridge has been unplugged for quite some time, and this is very important because there are capacitors underneath this cap that can hold a charge for quite some time. So if you're following along, you're doing so at your own risk. So here I go. I'll just get these screws out of here. It's been some time since I've been in here. I will explain that very soon. Okay, so here is the controller board for this fridge. And in order to get this out, I need to remove all of these wires. Now, everything is indexed and everything is a different size in here. So what I need to do is remove all of these connectors. So again, I know that there is no charge on this board right now. So I'll just unplug all of these like so. They very easily come off. And remove all of these from the top side. So all you do is you pinch this little tab down and pull back, and then these all come off. This one here's a little harder to get at because there's capacitors in the way. And there's these little plastic tabs that just lock in place. This isn't screwed in or anything like that. So all you need to do is press this little tab in on the side and then pull forward, and you can see it just comes loose. So you look for the little tab that's protruding out of the side, and you can just squeeze those little tabs together, and then the board will just come out. This one here is a little rougher to get at, just like so. So let's head back to the lab and take a look at this, and I'll explain what's going on. Here we are, back in the lab, with the controller board out of my fridge on the bench. Now, I'm no stranger to this circuit board. About 7 years ago, this board had a pretty bad failure point, and a lot of other people suffered from this failure as well. And I think you can see the solution right here that I designed for this board. I designed another little circuit board to sit on top here. And I'll explain a little bit about this in just a while. So what happens with this board here, and what's happened to a lot of people, is when you close the door on your fridge, the lights stay on. And that's a big problem with these refrigerators, especially way back when, because they had incandescent bulbs inside. Incandescent bulb means that they have a filament inside them and they get really hot. So when you shut the door on your fridge, the bulbs don't go out, and since the bulbs are on the upper portion of the fridge, the top shelf is really close to that area. It gets really warm inside the fridge and food spoils. It can cause a whole bunch of issues, and a lot of people were dealing with this. A lot of people had, way more serious issues than I had with mine. I caught mine pretty early. So when you find that the freezer is still working very well, but the refrigerator on the top is getting warm, this is when you start to inspect things. And of course, I found that the lights were staying on, even though the switch on the top was pushed in by the door. So the lights were just stuck on. And this is a mistake that's made by young engineers. Well, what happens with incandescent bulbs is when they're cold, the filament inside is a really low resistance, so it's closer to a short. When the bulb gets warm, so when the filament starts to glow, the resistance climbs high. So there's no problems. They draw their specified amount of current when they're nice and warm. But when they're cold, especially inside of a refrigerator, depending on where in the AC cycle you open the door, the contacts in one of these relays will close. And if those two incandescent bulbs have cold filaments inside them, it can draw a lot of current for a very short period of time until that filament warms up. That excessive current draw will weld contacts inside of a relay. So when the relay closes, it goes spark, and then they can't release because they've welded together. And that's what happened on this board here. So I designed this little solid state relay board here for both the refrigerator and the freezer lights. And this isn't just a standard type of solid state relay. These optos here are known as zero crossing opto-isolators, and they're special because they turn these triacs here on when the cycle is very close to zero cross. And in order to explain how that works, I need a piece of paper that'll help you greatly understand how relay contacts weld together and how something like this is a very decent solution. I've had absolutely no problem with this circuit here, and I've gone through light bulbs in the refrigerator since then, and the circuit still remains nice and strong. So I'm not worried about this. It's the rest of the board in this video that needs to get fixed at this point. So I'll get a piece of paper and I'll explain what this little board is doing. In order to understand why the relay contacts are welding together, we need to take a look at what's actually going on. So first of all, in the wall outlet of your house, you have 120 volts AC at 60 cycles per second. So that is one whole cycle. This is known as zero cross right here, right here, right here, and so on as we go along. This is 0 volts right here. Now, oscilloscopes show peak values. In order to make this a little bit easier to understand, we'll just use the RMS value, what your standard DMM will read. All right, so we'll go positive 120 volts AC here, right at the top, and we'll go negative 120 volts AC right there. So what's happening is this is changing continually in your wall outlet. So we have it going to positive 120 volts AC, and then it comes back down to 0 again, 0 volts. And then it changes polarity and goes negative 120 volts AC. So the polarity in your wall outlet is continually switching back and forth like this. That's why it's called alternating current. Now this is one whole cycle right here, and there's 60 of these in 1 second. So that's what it is. 60 cycles per second is how many times this is moving, right? So it goes positive and negative in one cycle. And then, so that would be one cycle, and then another cycle and another cycle. We have 60 of these in 1 second. One easy way to remember AC is if you have an AC signal that looks like this, right? If you join your fingers like this, you get a circle, right? The way I'm twisting my hand here on camera, it's not looking quite like a circle, but you get a circle, one complete cycle, one circle. All right. Now, when you're opening the door on your refrigerator, this is moving. You're not in sync with this. All right. So this could be anywhere in the cycle when you're opening that refrigerator door. So this is starting at 0 volts and it climbs up to 120 volts AC, and then it goes right back down to 0, and then it changes polarity and it's going to negative 120 volts AC, coming back up to 0, and it's just doing this. Now, you can open the refrigerator door anywhere within this cycle because you're not in sync with this. So if you could be very, very fast and you knew the times, you could open the door when this is at 0 cross right here. So it's at 0 volts. So just say that relay closed to turn on the lights in your fridge at 0 cross. Well, there's no voltage there, and there's no current being supplied to those bulbs. So what happens is when the contacts close, there's no spark. Right? And it would just, the light bulb would turn on with the cycle, right? Now what happens is since it's random, you can open the fridge door at any time. You could open it when it's here on the cycle. So, the voltage might be climbing, right, to 120 volts AC, or you could open the fridge door right there. All right, that would be the worst place to open the fridge door, because what's happening now is the contacts in the relay will go click and close at this point. Well, this is supplying maximum current at this point, right? 120 volts AC at maximum current. It's just going bam like this. So you're going to get a spark in there. When these spark like this, they spot weld together. Now, this doesn't happen with any relay or with just any relay. If you have a big enough relay, they can deal with this. They can close and spark and be just fine. But these relays here cannot deal with that load, especially with these two incandescent bulbs in parallel in the fridge. So what's happening is just say throughout the entire life of your fridge, you're lucky. It's like winning the lottery. Every time you open the door, you opened it at 0 cross here. So what would end up happening is the switch contact, or the relay contacts would close and it would climb with the cycle and it would be absolutely fine. The contacts would never weld. Well, the chances of that are very, very slim. There's a really good chance that you're opening and closing the door all over the AC cycle. And of course, if it's anywhere on the AC cycle like this, you're going to get a spark. And since the filaments are cold, the resistance is very low. So it's closer to a short. And this has to supply maximum current as soon as those contacts close. Again, you get the spark and they weld together. All right. Now, what's happening with this little circuit that I've designed here, these are known as triacs. So basically AC switches, okay? These two little white blocks that you see here are known as zero crossing optoisolators. So what happens is, just say the switch on your door, say you were to open the door on your fridge and the switch was to supply current. So this little processor right here, this little microcontroller here, is now telling this opto to turn on at this portion of the cycle. Well, this little block says, no, wait a minute. So what it does is it waits until it gets very close to 0 cross, and then it turns on the triac. So these things wait until it's at a point very close to 0 cross to turn it on. That's much easier on the switch, and it's much easier even on the bulb. When I discovered that both the freezer and the refrigerator were warm, I immediately started the troubleshooting procedure. Now, I was very careful while doing this not to disturb the original failure point. This is absolutely crucial in finding a problem, especially a problem like this. So I listened for the compressor. The compressor was off. When I opened the freezer door, the freezer light did not come on. When I opened the refrigerator doors, the refrigerator lights did not come on. So at this point, I'm thinking that there may be a problem in the power supply here because nothing is happening. Now, in the back side of the freezer, I hear a crackling and a hissing noise. To me, that sounds like the defrost heater. So I put my hand on the plastic on the back side of the freezer, and it's nice and warm. So everything is off except the defrost heater. Well, immediately that tells me that this relay here has most likely stuck. This is the relay that controls that. What's happened is the processor most likely told this entire board basically just to shut down. It told the fridge to shut down because the fridge won't come to temperature within a certain time period. So it's just shutting the thing off. So it's run and run and run and run, and it just won't come down in temperature because it's fighting this heater. There's a heater on, the defrost heater, right? It's basically trying to melt things, and it's creating heat in the backside of the freezer. It can't fight that, so it just shut down. So my first thing that I'm going to be doing is I'm going to be replacing this relay. In fact, I'm going to replace all the relays in here because this thing has been in service since 2007 now. That's when this fridge was built and put into service. Now, these capacitors have also been working 24 hours a day, 7 days a week since 2007. What does that mean? This thing needs to be recapped. This thing isn't cycled. It's not something that's turning on and off. These things are on 24 hours a day. So what I'm going to do now is order up brand new relays. I'm not concerned about the value of this particular relay because this has been in service again since 2007, and chances are the contacts in here have just, from sparking on and off, chances are the plating is worn off and they're sticking. So something as light as tapping a relay like that, a lot of the times will free it up. And it's the same thing with these original relays. The ones that I replaced for the lamps, all I had to do was just tap them and they would let go and they would work again. Just that easy. So again, anything can disturb a failure point in something like this. So that diagnosis procedure allowed me to find that this here is sticking on and the fridge is just, it can't fight that amount of heat. It just won't come to temperature. So just the whole thing has shut down. So that's my next line of repair here is what I'm going to do is just replace all of these relays. I'll leave this solid state board in because, for the lights, that's a really great, it's a great feature in this fridge because you don't have any contacts moving. It's all solid state, right? And if anything's being cycled, it's those lamps. Every time you open the door, those lights are coming on and off and on and off. So I'm going to replace this relay, this relay, this relay, this one. This is the compressor relay right here. I'll replace that as well. And all of these electrolytic capacitors, every single one of them, I'm going to replace with a brand new high quality device, high hour capacitors. So ones that will last a very, very long time. Now, they were nice enough to put a legend on here so you can follow this right to the relay. You can follow the wiring. Defrost heater is here. We have freezer lamp, which is this right here. Refrigerator lamp, which is this. We have valve 2 and valve 1. So if we look on the backside, they've even marked it on the backside. They were really nice when they built this board. A lot of companies don't do this. So you can see valve 2 and valve 1 are just one relay. They're hooked together. And then we have front door heater, which is this right. So it heats the actual seals of the door. So that way it heats the actual door so that when the doors close, they don't, stick, especially the freezer, because if there's any moisture in there and it gets really cold, you don't want it to stick. So they have heaters in there as well. And of course, that also helps. I've felt around the actual door and the doors are nice and warm themselves. So I guess it stops the refrigerator from also cooling your house down as well, but at any rate, right around the seals is where it's always nice and warm. So you can see on the back side, it's, really straightforward, single-sided board, it's just, everything is really, really well laid out. This looks like probably a ULN 2004 or 2003 or something like that. I can't really see that here. So just a relay driver. They're using this as a relay driver. So the outputs from the processor right here drive this IC, and then this IC is what, drives all the relays to keep the load of the relays off the processor. So for some reason, all of the relays or one of the relays was not to work at all. This is the first thing. This actually protects this IC from this side, which is kind of nice. So Nice little bit of isolation between the processor and the coils of the relay. So just pretty straightforward stuff. You can see up here everything is all labeled at the top as well. So you can see here. So freezer sensor, refrigerator sensor, door sensor, front door switch, stepper motor. And then the display, this runs up to the little LED display with all the selections on the front so you can adjust the freezer and the refrigerator temperatures. So, and it just has everything, you know, pumps and doors and fans, all that kind of stuff. Just, you know, everything is very well laid out. So they did a nice job putting this thing together. The board itself, it's just too bad they didn't design this little area a little bit better. So I'll get that underway. We'll get the board back in the fridge. We'll see what happens. Okay, parts are in. Let's take a look in here. Brand new relay. Right there. So that is that. Nice thing about DigiKey is they do such a nice job packaging this stuff. No, I'm not sponsored by DigiKey, but they do. It's just, everything is just packaged so incredibly nice. I ordered a bunch of other supplies as well, and everything is, you know, just wrapped so nice. The heavy stuff is at the bottom of the box, and the light stuff is at the top. Just, you know, good planning at any rate. New replacement cap right there. Very high quality capacitor. And I ordered some extras. Ordered a few more. Look at this, you know. So thorough. The person that did this was very thorough. I taped 2 spots to hold this relays in place. Let's see here. Okay. There we go. So there, all brand new relays. So I'll replace these ones. I'll have 2 as spares just to put in the box, because these are nice little relays. Nice relays to have around maybe for another project or something like that. Because at this point, I doubt that I'll be replacing these again. So again, these will just stay in. The solid state switch works very, very well. So getting this out looks to be relatively easy. So, right here. And just like that, it's out and ready to be replaced. So I'll end up doing that with all the rest of the components, replace them all, and we'll try this thing out. All the relays and electrolytic capacitors have been replaced. So at this point, it's pretty much ready to try out. I've cleaned off all the flux residue on the back side of the circuit board. And on the bench here, you can see all the components that have been removed from this board that have been replaced. So time to put this thing back in and see if the fridge works. Okay, let's see if this thing comes to life. So I'll put the circuit board back in. And so here. So, there it is. Here's the line cord. Let's see what happens. Here we go. That is a really good sign. So the compressor started up, and I hear the PWM of this little IC for the fans inside. So all is looking good. The fridge has been on for a short period of time now. As you can see, the display is working. Let's take a look at the temperature. So I'll zoom on in. I just put this little thermometer at the back side of the fridge. Focus in on that. And as you can see, it's very comfortable within the green zone, which makes me extremely happy. And if I zoom back out here, you can see the fridge light turning on and off. You hear the fan starting up. You hear the PWM there. So everything is working great. The fridge is back in working condition, which makes me extremely happy. I hope you enjoyed troubleshooting and repairing this refrigerator with me today. If you are enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. We'll be repairing, troubleshooting, and even reverse engineering modern and antique electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. If you want to be notified as soon as I post a new video, don't forget to tap the bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, you're going to want to check out my ongoing electronics course. I'll put the link just below the video description, and I'll also pin the link right at the top of the comments section. I'm also sharing many of my personal electronic circuit designs there for customized test gear to make your troubleshooting procedures all that much more easy. So there's a lot of really interesting things going on there. Definitely check it out. All right, until next time, take care. Bye for now.